In this fourth video, what we're going to do is we're going to have a look at integrating terms with a bracket. Now, in this bracket, the key thing is it's a linear term. What that means, it's got an x, it's got a number term, or it could just be an x term, but it must not be a higher power than x. This technique only works when the bit inside the bracket is a linear term. So let's have a look at this first one. Now, what we have to do is we treat the whole bracket as if it were an x. So we raise its power by 1 and we divide by the new power. So if I'm looking at that, that becomes 5x plus 2 to the power 6 all over 6, which is divided by 6. Notice I've left a space here, because what we then have to do is if I differentiated the bit inside the bracket, I would get 5. Yeah, the number term disappears, the x term turns to a number term. So what I must do is I must multiply the bottom by 5. And the other thing I must do is I must remember to add on my constant of integration. Now, we can tidy that up a little bit in that it's 5x plus 2 to the power 6 all over 30 plus c. So to remind you, the bit inside the bracket must be a linear term. Then what we do is we raise the power of the bracket by 1, divide by that new power. Then we differentiate the inside of the bracket, which just gives me the coefficient of the x, which is 5, and I multiply the bottom of the fraction by that as well. So, leaving us in this case 5x plus 2 all to the power 6 over 30 plus c. This one doesn't look very much like that, but actually it is. Okay, so the first thing I have to do is write it in this sort of form. Now, remember, if we say square root, we really mean the second root. So it's an implied 2 there. So this I could think of first of all, remember the root is the bottom of the fraction in the index and the power is the top. So we could think of it as 2x minus 1 to the power 3 over 2 dx. Now, we want that on the top line. Remember, if we raise it to the top line, we show that by putting a minus in the index here. So that's the same as 2x minus 1 to the power minus 3 over 2 dx. Okay, we've now got it in a form where we can integrate it. That's just a multiple, so if you wanted to, you could even think of it like this. Yeah, we don't have to put it on the outside there, but it just sort of points out that when we integrate this, okay, when we integrate this, it's multiplied by 3. Yeah, so we're not integrating the 3, we're integrating this bit. So, again, raise the power by 1. Divide by the new power. Then differentiate the bit inside the bracket, which gives us 2, and multiply by that on the bottom. Not forgetting our plus c. Okay, I'll just go over here so I've got a little bit more space. We want to tidy this up a little bit, okay? Minus a half times 2 is minus 1. And remember, dividing by minus 1 just changes the sign. So we can think of that first of all as that. Okay, but we were given it in power and root form here, so we should really give it in power and root form back here. Remember, if, first of all, the power only applies to the bracket. It does not apply to the minus 3 at the front. So the minus, remember, shifts this bracket to the bottom line, and the half means it's the square root of that. So if we put that together, the minus 3 stays on the top line, and then it's going to be the square root, that's from the half, remember it's on the bottom because it was minus a half, of 2x minus 1. And don't forget to put plus c. So this was a fairly straightforward example of this type of thing. This one required a little bit more work. And you should now be able to do the fourth exercise.